Good morning. Today we're going to be learning about the percents of increase and decrease, or another way to think of that is the percent change. So first you need to understand what percents of increase and decrease are. At the top of the page here, percent of increase is defined as when the original amount increases, the percent of change is called a percent of increase. In order to calculate the percent of increase, we'll use this formula. It says here that the percent of increase is equal to the new amount minus the original amount divided by the original amount. Another way to think of this is to take the greater amount, the greater percentage, subtract the lesser percentage, and then divide that by the original amount. Underneath that, we have the definition of a percent of decrease. Decrease means to go down. When the original amount decreases, the percent of change is called a percent of decrease. In order to calculate the percent of decrease, you start with the original amount, subtract the new amount, and divide that again by the original amount. In the example with a percent of decrease, you are still starting with the greater. Here, the original amount is greater because it went down. So you should just think of a percent change as the greater percentage minus the lesser percentage divided by the original amount. This would be a good point where you would stop the video, pause the video, and write these two formulas into your notes because you will need both of these in order to calculate percent change on the next slides. Here's an example. In this one, we're finding a percent of increase. It says that the table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? So looking at the table, we can see here, it shows the two different days, Saturday and Sunday. On Saturday, you spent 2 hours online. On Sunday, you spent 4.5 hours online. What you would do at this point is you would think about which of these numbers is greater. Since 4.5 is greater than 2, you know that the formula is going to begin with 4.5 on the top, subtracting 2. You also know that this would be a percent of increase because as the time goes on from Saturday to Sunday, as time passes, the number of hours online goes up. So you would start by plugging in 4.5 minus 2 on the top, and then you'll divide that by 2. Subtract on the top. A fraction bar is similar to a grouping symbol when it comes to PEMDAS or the order of operations, so we'll want to complete everything on top of the fraction bar before we divide. Then we can use your calculator to do 2.5 divided by 2, which you can see here they already have shown you that the answer is 1.25. But remember, we're solving for a percent. The number you got is a decimal, so you'd move the decimal from 1.25, you would move the decimal 2 places to the right, or that's the same thing as multiplying by 100, and then you would put your percent symbol. So 1.25 is the same as 125%. So your online time increased 125% from Saturday to Sunday. Okay, let's try an example here. The directions say to find the percent of change, round to the nearest tenth of a percent if necessary. So first you would look at the starting amount and the ending amount. This goes from 10 inches to 25 inches. First you would want to know, okay, is it going up or is it going down? Since 10 inches is getting bigger and going to 25 inches, we know first that this would be a percent increase. And then we would look at our formula for percent increase. We're always going to start with the larger amount. So we would start with 25 inches minus 10 inches all over the original amount, which we know the original amount would be the starting position. And since it says from 10 to 25, 10 is what we started with. Now we'll subtract 25 minus 10, which is what? 15. Divide that amount by 10. And here again, you can use your calculator, but I know that 15 divided by 10 is just a shift of the decimal. So we're going to take that decimal and we're going to go left once. So this is 1.5. Now you should be asking yourself, is that the percent? Because we are trying to find percent here, or is that a decimal? If it is a decimal, we'll need to convert to a percent. And you should be thinking, what do I do to a decimal to convert to a percent? And if you said that you are going to move the decimal to the right 2 places, you're absolutely correct. If you bounce past nothing, we have to put a 0 there. So the percent of increase here is 150%. Here's an example of finding a percent of decrease. This example says the bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? So when we look at the table, here it says softball is the title. I notice the amount of home runs is along the bottom, and the season starting with the most recent, so from 2013 to 12, 11, and then 2010. If we're trying to find the percent of change from 2012 to 2013, those are the 2 numbers that I'm most interested in here. So from 2012 to 2013, as time passes, meaning from 2012 to 2013, the amount goes down from 28 to 20. Because it goes down, I know it's a decrease. As always, our formula here for percent of change would be the greater amount minus the smaller amount divided by the original amount. Since 28 is the greater amount, we'll subtract 20 and divide that by 28. It works out that 8 is going to be divided by 28, and when we use our calculator for that, it comes out to a decimal number. When you put that amount, 8 divided by 28, into your calculator, you should get a long decimal number. And I have here the first 4 decimal places. We're going to stick with rounding to the 10th of a decimal. So the first step would be to move the decimal twice so that we have an actual percent, not a decimal. And if we're rounding to the nearest 10th place, you should think, okay, well, what number is in the 10th place now? A 5 is in the 10th place now, but it's the bossy neighbor next door to the right that tells that 5 what to do. Remember, he says 1 through 4, stay on the floor. 5 through 9, climb the vine. In other words, if the number that is telling the rounding place what to do, if it's 5 or higher, it says to go up. So that's why in this example, 5 is rounded up to 6. Everything in front of that stays the same, and everything behind that falls off. This would be 28.6%, and that is a decrease. Let's try this example. The directions say to find the percent of change, round to the nearest 10th of a percent if necessary. So it starts with 65 people and then it goes to 57 people. Since this is our starting point, 65, and the number is going down, we would say that this is a percent of decrease. And our formula, we always begin with the greater number. So that's 65 minus 57 in the numerator, all divided by the original amount, which is 65. Remember to treat the fraction bar like a grouping symbol, so we'll subtract 65 minus 57 on the top first. You should have gotten 8, and then we'll divide that by 65. So we'll want to use our calculator here. 8 divided by 67 is approximately, so the squiggly line, is approximately 0.1230. First, we would think This isn't a percent, so we'll move the decimal to the two places to the right to make it a decimal, which is 12.30. And since what is following the tenths place, 3 is in the tenths place, since it's a 0, this will already be rounded to 12.3% decrease. There's one other concept that is typically taught alongside percent change, and that's called percent error. And a percent error is defined as the percent that an estimated quantity differs from the actual amount. This would be a very good time for you to pause the Edpuzzle and write down this formula. The percent error is equal to the amount of error over the actual amount. Here's an example of finding a percent error. It says you estimate that the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. The amount of error is calculated by subtracting. If the actual amount was 21 feet and you estimated that it was 16 feet, we'll start with the greater amount, subtract the smaller amount, and we're left with 5 feet. Then we'll plug that into the formula that you should have written into your notes. The amount of error is 5 feet divided by the actual amount, 21 feet, gives us a decimal number that is approximately 238 thousandths. First, you would have to write that decimal as a percent by moving the decimal 2 places to the right, and you get 23.8%. So the percent error is about 23.8%. Another important note that you should put into your notebook right now is that percent error is always positive. So when calculating the amount of error, you always start with the greater number, subtract the smaller number, and the percent error will always be a positive amount. Here's an example with percent error. It says that you estimated that 200 people attended a school concert. The actual attendance was 240 people. Find the percent error, and what other estimate gives you the same percent error? How would you know? Take a minute right now and use the formula that you were given to see if you can answer this question correctly. First, we'll want to start with the estimated amount and the actual amount. It shows here that the estimated amount was 200 people and the actual attendance was 240 people. We'll always start with the greater number when we plug this into the formula. So you would start with 240 and subtract 200. And then in the denominator, you would want to be thinking, okay, what was the actual amount? In the denominator, we'll always want the actual number. So here we'll put 240. At this point, we'll subtract because the fraction bar acts like a grouping symbol, and that would be 40 divided by 240. Or if you want to think of this simplified, that's 4 divided by 24. You should get a long decimal that is 0.16 repeating. First, we would want to change our decimal to a percent, by moving the decimal to the right twice. Look to see what's in the tenths place, and then find the bossy neighbor that's going to tell it what to do. Since a 6 is greater than 5, it would tell us to round up, and our percent error is approximately 16.7%. Now, the second question was a good challenging question. It said, what other estimate gives you the same percent error? So you should be thinking, well, how do I find percent error? And the first step is to find the difference between the estimated amount and the actual amount. The actual amount isn't going to change. The attendance was 240 people. However, you underestimated on this. You also could have overestimated by the same amount. If you overestimated by 40, instead of estimating 200, you would have estimated 40 greater than the actual amount, which would have been 280 people. That would still give you an error of 40, and the actual amount wouldn't have changed. Here are two more examples for us to try. We're finding the new amount. Here, since we know that the percentage is a percent of decrease, sorry about that. Since we know that the percent change is a percent decrease, the first thing that we're going to do is see what the percent change is. So we're going to multiply the 50 points by 26%. Of course, when we put that into our calculator, we'll want to multiply that by a decimal number. So we'll do 50 times 26 hundredths. Go ahead and figure what that is. And we get 13. That means that the actual number of points has a change of 13. And since it's a decreased amount, we would subtract 50 minus 13 to see what the amount is. And 50 minus 13 would give us 37 points. So after decreasing by 26%, we would have 37 points as the new amount. So here's another example. It says 8 meters increased by 25%. So just like we did in the previous example, we would start with the amount we were given, 8 meters. We will then multiply that by the percent change. 8 meters times 25%, but when we put that into our calculator, we would put 0.25. 8 times 25 hundredths is equal to 2. Since this was an increase, should you add 2 to the original amount or subtract 2 from the original amount? If you said that you should add, you are absolutely correct. And 8 plus 2 would be 10 meters for the new amount. Here are several examples in which you're supposed to identify the change as an increase or decrease and then find the percent of change. This would be a good spot for you to pause the slide, try and figure these 4 examples on your own, and then come back to it to see if you're correct. The first example says 75 people to 25 people. What is the starting amount of people, and what is the finishing amount of people? Since it's 75 to 25, this would be a decrease, and our formula can always be thought of as the greater amount minus the smaller amount. So 75 minus 25 all over the original amount. So you should wonder, okay, what is the original amount? That is what I'll put into the denominator. At this point, we'll subtract and then divide. 75 minus 25 is 50, all over 75. You can use your calculator if you need to. 50 divided by 75 is a repeating decimal. 0.66 repeating. First, move the decimal to the right twice. I'm actually going to put one more decimal place so I'll know how to round. Now, which place is the 10th place? The 10th place is the first place to the right of the decimal, and it's the bossy neighbor next door to the right that tells it what to do. A 6 will tell the 10th place to go up, so we would have 66.7%. The next example says 68 miles to 42.5 miles. What should you set up in the numerator of this fraction? 68 is your starting amount, and it's the larger amount. So we'll subtract 68 minus 42.5. What number goes into the denominator? The original amount always goes into the denominator, so we'll put 68 here. Since our original amount went down, we know that this is, again, a percent decrease. Now you can use your calculator to help you solve. 68 minus 42.5 for the numerator, 25.5 divided by 68. and your answer comes out to 375 thousandths. Is this a percent or is this a decimal? Since this is a decimal number, we will move our decimal to the right twice to make it a percent. Don't forget to include the percent sign on your final answer, 37.5%. For the next example, it says 24 songs to 78 songs. Is this a percent increase or a percent decrease? Since the number goes up to 78, it is a percent increase. And what would we have in the numerator of our fraction? Since we always start with the bigger number, we'll have 78 minus 24. And what amount goes into the denominator? The original amount. So the original amount would be the starting amount of 24. So now you can use your calculator to help you solve these final steps. 78 minus 24 is 54. 54 will then be divided by 24. The amount that you got should be 2.25. In order to change this to a decimal, we'll move the decimal to the right twice, which gives us a percentage increase of 225%. And for our last example, 72 clips to 63 clips. The amount of clips went down, so this would be a decrease again. What would we have in the numerator of this fraction? Since we start with the greater amount, we should have 72 minus 63. And what goes in the denominator? The original amount, 72, will be in the denominator. 72 minus 63 is equal to what? 9. And we're dividing by 72. So you can use your calculator to help you. The decimal number that you got should be 0.125. When we move the decimal to the right twice, that comes out to 12.5% decrease. All right, ladies and gentlemen, in this lesson, you have learned how to find the percent increase or percent decrease using a formula. You also learned how to find the percent error given the amount of estimation versus the actual amount. Please make sure that both of these pieces of information are in your notebook and head back to Schoology to see what you should work on next for practice.